copper sulphate. So here's my setup of my electrolysis with copper sulphate as my electrolyte, and the ions that are present in this are your copper 2 plus and your sulphate ions, as well as the H plus and the OH minus that come from the water. So in this particular case, I'm using graphite electrodes, which means that they're completely inert and they're not going to take part in the electrolysis. They're completely unreactive. Let's have a look at what happens at the cathode. At the cathode here, I've got two possibilities because both the Cu2 plus and the H plus will be attracted there, and at the anode, the SO42 minus and the OH minus will be attracted there. So at the cathode, between these two, the copper is lower reactivity than the hydrogen. So that means that the copper will end up being discharged, will end up being reduced. So you end up with copper 2 plus picking up 2 electrons to become copper. At the anode, you have the choice between the sulphate and the hydroxide, but the sulphate never gets discharged. So that must mean that the hydroxide will get discharged to produce both water and oxygen in this equation here. Another example that you need to be aware of is what happens when you have copper electrodes being used instead of the graphite electrodes. So that's exactly the same as what we've got here. The ions are exactly the same as before, the copper, the sulphate, the hydrogen and the hydroxide, all present just like before. The only difference is that now my electrodes are made of copper rather than graphite, which means that they can get involved. Let's look at how that works. So at the cathode, I've still got the Cu2 plus and the H plus, and the Cu2 plus still gets reduced to make copper, meaning that that cathode is going to get bigger in size as the copper coats it with more and more layers of copper. At the anode, I've got the sulphate and the hydroxide as opportunities of things that could be oxidized, but also the copper could be oxidized there. Now, because the copper is more easily oxidized than either of the sulphate or the hydroxide, the copper is actually oxidized preferentially, which means that the copper metal can turn into copper ions and electrons. This means that the electrode donates copper into copper metal in the solution, and then at the cathode it can get picked up to turn back into copper metal again. You may be thinking, what's the point in this? You're just moving the copper from one place to the other. So let's have a look at it in the example of copper refining. This is how we purify copper. So at the anode, what I've got is a piece of copper ore, which is just rock that contains enough copper that it's worth extracting the copper from it. At the cathode is a really thin strip of pure copper metal. So the equations work exactly the same as the previous equation because I've still got copper sulphate as my electrolyte. So at the cathode, I've still got copper 2 plus from the electrolyte picking up 2 electrons to turn into copper metal. So you can see that copper 2 plus going from the solution and being attracted to that cathode and building up that cathode into a bigger piece of copper. At the anode, however, you've got the copper turning into copper 2 plus and 2 electrons. But because in this case it's a piece of rock, it's just those pieces of copper that will be oxidized to copper 2 plus. Anything else, all the sand and other stuff that's in the rock, will just fall to the bottom because it's not going to get put into solution. So this means I can separate the copper out of the rock because that turns into copper 2 plus in the solution. Now, over a period of time, what happens is you end up with your copper cathode getting bigger and bigger and bigger as more and more copper gets coated around it, whereas my copper ore anode will get smaller and smaller. And what will end up happening is all the sand and other stuff in the rock will just fall to the bottom like a sludge at the bottom there. And what I've got that's different from the beginning is now I've got a massive piece of pure copper metal, whereas before it was just rock with a bit of copper in it. Okay, cool. So that's how we use electrolysis to purify copper, using copper electrodes rather than those inert graphite ones.